Good morning, children. As many of you had doubt in this question 9b, I'm just going to solve that first. Show that the quantity 2k by v square has the unit of mass where k is the kinetic energy of the body. So they've given you a term 2k by v square and we have to prove that it has the same unit that of mass. So you try to write the term and write the values also. Okay, 2k by v square. Now k is kinetic energy. It's given k is kinetic energy. So what will be the unit of, you have to write it in terms of basic units, fundamental units. Okay, so kinetic energy, the unit is joule. What is 1 joule? 1 joule is 1 Newton into 1 meter. This is not fundamental again. Okay, you can just take like this. Otherwise, kinetic energy is force into displacement, and force is m into a into displacement. So mass is in kg, acceleration meter per second square, displacement is in meter. So kg meter square by second square. So that's the unit of kinetic energy. And velocity, meter per second. So now let's put it in this one. 2 into kg meter square by second square upon velocity square. So meter by second, the whole square will be meter square by second square. So these two will get cut. Leave the constant term. The main part is this unit kg, which is the unit of mass. So this is how you have to prove that this term has the unit same as that of mass. Okay, and another thing which you all had not done, that is in the derivation for kinetic energy, you all have started from this assumptions. Okay, let's consider a body of mass m moving with velocity v. You have to write this point also. This is like the principle, like this is what the concept that we are going to use in this derivation is this one. It can be calculated by finding the amount of work needed to be done by an opposing force to stop the body. So make sure you write this. So in your notebook also, above the derivation, please write this and keep. Okay, now we have to start with the last part of this chapter, different forms of energy. So as you know, energy is in different form: heat energy, light energy, chemical energy. So this page you can just go through it, and the main thing what they ask actually in this year is, in 10th standard, is conversion of energy. Okay, they'll give you a particular device and they ask you what kind of energy conversion takes place. These are some examples given. One is, first is dynamo. Dynamo is the other name for generator, the generator that we use to generate electricity. So what is the energy conversion in that? Mechanical to electrical. You pour diesel into the generator. There is a motor or a shaft that rotates, and output what you get electrical energy. So mechanical to electrical. Motor does the opposite, electrical to mechanical. Press box, electrical to heat. And thermocouple, this is a new device for you, heat back to electrical. Okay, now loudspeaker and microphone. Now microphone, we usually speak in front of mic, so sound is the input, it converts it into electrical energy. Okay, whatever we speak, those sound energy is converted to electrical energy and goes through this wire. And then what does the loudspeaker do? The wire, it converts electrical back to sound. You hear from sound, you hear from loudspeaker. So for loudspeaker, output is sound. For mic, input is sound. Remember like that. Charging a battery. So while charging a battery, electrical to chemical. While cell is in use, when the cell is in use, the stored chemical energy converts back to electrical energy. So, like this, you can just go through it. And photosynthesis, chemical light to chemical energy. Okay, photocell, light to electrical energy. So these are some of the examples given. There are some more examples given in this page also. I want you to mark them. Steam engine, okay, steam engine, heat energy of steam changes to kinetic energy of piston. Then burning of fuel, okay, burning of fuel, chemical energy changes into heat energy. Then explosion of crackers, chemical to heat, light and sound. Remember that, okay? In a when a cracker explodes, you get all three forms of energy as output: heat, light and sound. Then lighting a candle, chemical to heat and light, okay? Respiration, chemical to heat. Photosynthesis is light to chemical, respiration is chemical to heat. Remember that clearly. Automobiles, what happens in an automobile? Chemical energy of petrol or diesel is converted to mechanical energy, or you can say specifically kinetic energy. Electromagnet, the next device is electromagnet. What happens? Electrical energy changes to magnetic energy. Nuclear reactor, nuclear energy converted to electrical energy. Okay, in dams, when water falls from a height, potential energy changes to kinetic energy. Moving part of machine gets heated due to friction. What is happening? Part of mechanical energy changes to heat energy. So the question that usually comes from this part is, mention the energy change in the following. Now based on this, there are two exercise questions which I want you to try. Question number 24 and 25. Okay, so state the energy change that occurs in each of the following. So use a pencil and write it here itself. Write it here itself. You can use some short forms. Okay, PE to KE. Okay, or electrical, ELEC, you can write to mechanical, MECH. So like that, you use some short forms to write it with a pencil. Write it here. If you have any doubt, we can we can discuss it later. Now we'll start with the numericals um, of this chapter. Okay, there are quite a lot. We are going to try and finish them today. Okay, so but they are very simple. Each numerical just has one step or two steps, which is very rare in physics. Okay, so we'll try to complete as much numericals as possible so that I can give you less homework. Now the first one. So what are the formulas that we are going to use for solving the numericals? One is kinetic potential energy, gravitational potential energy or potential energy, mgh. Then kinetic energy, half mv square. Momentum, mass into velocity. What does work energy theorem say? Work done is equal to increase in kinetic energy. So half m v square minus u square. Okay, here there will be loss in potential energy and gain in potential energy. So you will have formulas for that also. So these are the formulas that we'll be using in solving all these numericals. Now we'll start with numerical number 1. Numerical number 1. So two bodies of equal masses are placed at heights h and 2h. h and 2h. Find the ratio of their gravitational potential energies. Two bodies of equal mass. So their masses are equal. Okay, let's take this as body A, this is body B, and kinetic energy is equal, sorry, potential energy, right? Gravitational potential energy, or if you can use the symbol U. UA is equal to mgh. UB is equal to mg into 2h, because its height is 2h. So they've asked the ratio. So UA by UB will be mgh upon mg into 2h. So mg cut, hh cut. So 1 is to 1:2. Second one, find the gravitational potential energy of 1 kg mass. So children, as you watch the video, please note down the numericals. One more thing I wanted to tell you. You all, the last time when I gave the numerical homework, I could see only the homework numericals written in the notebook. What I would suggest is you keep solving the numericals. Suppose 1, 2, 3, fourth one I give as homework. You pause the video and do the homework, complete the homework, and continue writing it in a sequence way. So when you click the picture and send, I want to see all the numericals, both classwork and homework. Remember that. Okay, second one, find the gravitational potential energy of 1 kg mass. So mass is 1 kg, kept at a height of 5 meter above the ground. Calculates its kinetic energy when it hits the ground. First we have to find potential energy. Potential energy is mgh. 1 into g, they have told you to take it as 10 meter per second square. So 1 into 10 into 5, that is 50 joule. Now this is a dropped. So this is a stone dropped from a height. So potential energy gets converted to kinetic energy. So kinetic energy will also be 50 joule. Whatever potential energy it had at the top, that will be the kinetic energy at the bottom. So you need not do any calculation. You will just write the same one. Third one, a box of weight 150 kgf. So 150 kgf has gravitational potential energy equal to 14700 joule. Find the height of the box above the ground. Take G is equal to 9.8 Newton per kg, meter per second square, all are one and the same. So U is equal to, now they have given W. So what can you do? If W is given in kgf, mass I can just take in kg. W in kgf, the same thing I can convert it to mass and use the same number without any conversion and write it as kg. So U is equal to mgh. Now we have to find the height. So that is U upon mg. So U is 14700. Mass is 150 into 9.8. So 14700. If you multiply this, you get 1470. So you get 10 meter as the height. So height is 10 meter. We'll go to the fourth one. Mass is 5 kg. A body of mass 5 kg falls from height 10 meter to 4 meter. Calculate loss in potential energy. This is loss in potential energy. Okay. So mass of the body 5 kg. H1 10 meter. H2 4 meter. And we have to find loss in potential energy. So G is given as 10 meter per second square. So loss in potential energy is equal to mg, bigger one minus small one. Okay, h1 minus h2, h1 minus h2. So 5 into 10 into 10 minus 4. So 50 into 10 minus 4 is 6. 5 6 are 30. 300 joule is the loss in kinetic energy. Second one, total energy possessed by the body at any instant. Total energy at any instant. Now total energy will be the energy which had at the highest point. See, it was initially at this height at 10 meter. Then it came to this height which is 4 meter. So it lost some potential energy. That is what we calculated. Now if they ask you the total energy or the original or the initial energy, that will be the energy it had when it was at a height 10 meter. So mgh, you have to take h as 10 meter. So 5 into 10 into 10 meter, that is 500 joule. Okay, So total energy 500 joule. Loss in potential energy 300. Total energy is 500. Okay. Now, fifth and sixth. Fifth is the homework. Okay. Fifth numerical is homework. Then come to sixth. All the questions are very simple, just 2-3 steps you will have. Okay, nothing very complicated. A boy weighing 25 kgf climbs up from first floor of a height 3 meter above the ground to third floor. So from a lower height is going to a higher height. Then there will be gain in kinetic energy or increase in gain in potential energy or increase in potential energy. So a boy weighing 25 kgf climbs up. So in this case also weight is given as 25 kgf. Now we are solving the sixth one. So mass is 25 kg. And then height h1 is 3 meter and h2 is 9 meter. G 10 meter per second square. So gain in kinetic energy, potential energy or increase in potential energy is equal to mg h2 minus h1. So 25 into g is 10 into 9 minus 3. So 250 into 6, 25 6 are 150, 1500 joule. That is the increase in potential energy. Now 7 and 8 are homework. Okay, so pause the video and you try to solve these two questions. Come to the ninth question now. A block A weighing 100 Newton is pulled up a slope of length 5 meter by means of a constant force 100 Newton as illustrated in figure. So this block is pulled up along a slope. Okay, and the height of the slope is 5 meter. So its final position is here, which is at the vertical height above ground is 3 meter. So what is the work done by the force F in moving the block A 5 meter along the slope? So two heights are there. Be very careful in this. Okay, you have one 5 meter also, one 3 meter also. So the first part, what is the work done in moving along 5 meter slope means you have to take the distance as 5 meters. So work done is equal to force into displacement, and force is given as 100 Newton. Okay, you are using a 100 Newton force to push it, and displacement is 5 meter. So 500 joule. Work done to carry it along the slope. Okay, the work done to carry it along the slope of 5 meter is 500 joule. Now the second part, what is the increase in potential energy of the block A? Okay, so increase in potential energy means, so mg h1 minus h2. So it was at 0, means it was at the ground, and finally it has reached a height of 3 meter above the ground. You don't have to take 5 meter now. When you're calculating potential energy, remember you just need the vertical height above the ground. So 3 meter. So your h2 will be 3 meter. So h2 minus h1. So m into g, m is m into g, you can take it as 100 Newton because that's the force, into 3 minus 0 is 3. So 300 joule. Okay, so the potential energy at this point is 300 joule. Okay, now C part, account for the difference in the work done by the force and increase in potential energy of the block. Now they're asking, why has the kinetic energy, why has the potential energy decreased? Okay, now it took 500 joules to reach here, but its potential energy is 300 joule. Now where did this 200 joule go? The difference is 200. Where did it go? It was used in overcoming the friction, because as it is moving along a slope, so there will be constant friction and some energy will be wasted in it. Can you understand? So it took 500 joules to reach here, out of which 200 got wasted to overcome friction. So finally, when it was here, it has only 300 joule as the potential energy. So you can, they have given the answer also clearly. You can write it from the book. 200, the difference 200 energy is used in doing work against force of friction. Okay. 10th is fine. So far it is potential energy. Now we are starting with kinetic energy. Find the kinetic energy of mass 1 kg moving with uniform velocity 10 meter per second. Okay, so with this, now we are starting with potential. This was 9. That is 9 here. 10th one. Kinetic energy is equal to half mv square, half into mass is 1 kg, v square is 10 square. Okay, so half into 1 into 10 into 10. So this will be 50 joule. Okay, it's very simple, just direct substitution. Now 11, 12 and 13 are important, okay, because this is something to do with comparison. Okay, logical questions I can say. So these are very important. So we'll start doing them. 11th one, if the speed of the car is halved, how does its kinetic energy change? Okay, speed of a car, okay, is half. Okay, so you can take it as original or old and new. Okay, originally it was, the speed was, if the speed was v, the new speed is halved, that is v by 2. Can you understand? Originally if its speed was v, the new speed is v by 2 because it is given speed is halved. Mass will be the same because it's the same body, so mass will be same. Now original kinetic energy is equal to half mv square. New kinetic energy is equal to half m into v by 2 the whole square. Okay, so it will be half m into v square by 4. So what you do, don't multiply it, you leave half mv square and only the remaining term you bring it out. So 1 by 4 of half mv square. Now half mv square is its original kinetic energy. So half mv square was the original kinetic energy. So in place of that I can write. So the new kinetic energy is 1/4 of the original kinetic energy, or it becomes 1/4 or decreases by 4 times. You can write it in any way. So this is how you solve it. Okay, original, new, and then do the comparison. Please don't multiply and write 1 by 8. That will make it complicated. You write 1 by 2 half mv squared, you keep it so that you can compare it with the original kinetic energy. Coming to the 12th one, two bodies of equal mass are moving with uniform velocities v and 2v. So again these are two different bodies but equal mass. So A and B, mass m, okay, equal masses, are moving with uniform velocities v and 2v. Find the ratio of their kinetic energy. So kinetic energy of A is half mv square. Kinetic energy of B is half m into 2v the whole square. So it is half m into 4v square. As I told you, don't cut it. You keep half mv squared. So only the remaining terms you will group. So half mv square. Okay. So now they've asked you to find the ratio. So kinetic energy of A upon kinetic energy of B will be half mv square upon 4 into half mv square. So these two will get cut. 1:4 will be the answer. Is it clear, children? So if they ask ratio, you do it like this. If they ask you just uh, how does it change, then you have to give it as answer like this. It becomes 1/4 or whatever it is. Okay. So according to the question, you have to answer. Come to the 13th one. Two bodies have masses in the ratio 5:1. So again, they are two different bodies, A and B. Their masses are in the ratio 5:1. So don't take 5 and 1, take 5m and m. The masses are 5m and m. Kinetic energies are 125k and 9k. Okay, because it is ratio, don't just take the number alone, 5 and 1. You take 5m and m, and kinetic energy 125k and 9k. What you have to find? Ratio of their velocities. Ratio of their velocities. Now, kinetic energy is half mv square. So from this you get v square is equal to 2k by m, or v is equal to square root of 2k by m. Okay, so v formula is 2k by m. Okay, so VA, velocity of A, will be under root of 2 into, so this is the kinetic energy. So 125k, kinetic energy is 125k upon mass is 5m. VB is equal to root of 2 into 9k, here kinetic energy is 9k upon mass is m. Okay, now this is 25, here is nothing, and if you take square root of 25, it is 5. Okay, so rest all you keep it inside the square root only, 2k by m. Same way, VB is equal to 9, we can take it out, root 9 is 3, so 3 root 2k by m. Left out ones are 2k by m. Now we have to find the ratio. So VA upon VB is equal to 5 root 2k by m upon 3 root 2k by m. So these two will get cut and 5:3 will be the answer. Is it clear, children? So if they ask you the ratio of velocities, use this formula and then solve it and get the answer like this. Okay. Now, next three are homework, 14, 15 and 16. In 14th, the speed, again 2 cases you have to find the ratio. Speed is given in kilometer per hour. Keep it in kilometer per hour itself and solve it. No need to convert it into meter per second. Generally, we convert it into meter per second, but in this case, you don't have to keep it in kilometer per hour because you're only going to find the ratio. Anyway, they'll get cut. Okay. 15, 16, again they are direct substitution of the formulas. 17th one. A body of mass 10 kg is moving with a velocity 20 meter per second. If the mass of the body is doubled and velocity is halved, find the initial kinetic energy and the final kinetic energy. So, a body of mass 10 kg. So, we are doing the 17th one. Body of mass 10 kg is moving with a velocity 20 meter per second. Velocity 20 meter per second. If the mass of the body is doubled, okay, the other case they are telling you to take, mass is doubled. So 2 into 10, 20, and velocity is halved. So 20 by 2, that is 10 meter per second. So they are asking you to compare, you can take case A and case B also. So you have to compare the kinetic energy. So kinetic energy of A will be half into m into 20 square. And kinetic energy of B, case B, will be half into 20, okay, mass is 20, velocity is 10 square. So 5 into 20 square is 400, that is 5 4s are 20, 2000 joule. And kinetic energy of B, this will get 10, so already there is 10 square, so you will have 1000 joule. So you have to find the ratio KEA upon KEB is equal to 2000 upon 1000. That will be 2 is to 1. 2 is to 1. So this one, because they have given, they are asked you, sorry, they didn't ask the ratio, I'm sorry. So initial kinetic energy is this one and final kinetic energy is this one. They can ask the ratio also. If they ask, you will do like this. Is it clear, children? And next 18, 19, 20 are also homework. Okay, so I'm stopping with 20th numerical. We are not going at 21, 20, 23 we do later. So for Thursday's test, I'll be asking only till numerical number 20. Okay. Now in this 18 sum, there is 1 kilometer per hour. Okay. This has to be converted to meter per second, because here it is not comparing. You're not finding the ratio. You have to calculate work done and power. Now you remember how to convert kilometer per hour to meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. So this numerical initial and final velocity, before you apply it in the formula, convert it into meter per second, and minute has to be converted to seconds. So that is all. You can solve till 20th numerical. So prepare well for your test and give the test properly. Okay. All the best, children. Study well. Thank you so much.